A major retail brand launches a new sneaker. The marketing team writes a single creative brief to promote the drop, and that exact same brief needs to populate every digital channel simultaneously. For the email campaign, the layout demands 5 distinct copy variations. Each variation requires a headline capped at 50 characters, a corresponding subheader, and a specific call to action button. Mobile push notifications require a completely different geometry. They have 2 distinct layers, a collapsed preview layer containing a subject line and preheader, and an expanded view that reveals the full message. Then there is the SMS text. No arrays, no headlines, no subheaders. Just a single sentence hard-capped at 80 characters. Same product, same input brief, 3 wildly different structural outputs, yet they are all generated in a single execution by the exact same artificial intelligence pipeline. Generating this spread reliably requires detaching the core generative prompt from the specific structural constraints of the final platforms. If you try to build a separate, hard-coded prompt for every single marketing channel, your codebase becomes difficult to maintain as new platforms are added. The solution is a unified orchestration layer, one central algorithm that processes the brief and handles all the platform variations simultaneously. The user provides the raw product data once. That data flows into a central router, which evaluates the target destination and dynamically splits the request into the required user interfaces. This architecture relies on 3 strict software pillars: rigid pydantic data schemas, a dynamic strategy routing pattern, and rule-based parsing logic. Reaching production scale is not a matter of writing clever conversational instructions to a chatbot. It requires wrapping generative models inside rigid, traditional software engineering patterns. To understand how this pipeline operates, we have to trace the final user interface backward to the data structures that dictate it. This diagram outlines an email schema, branching into nested arrays for headlines, subheadings, and calls to action. For mobile, it expands, injecting subject line and preheader fields. For SMS, it collapses into a single string labeled description. These pydantic models are not loose suggestions. They are strict programmatic contracts that the language model must validate against before returning a response. Defining these exact data shapes through schema validation eliminates the risk of a non-deterministic model breaking a downstream UI component with the wrong JSON format. If the system uses the exact same base prompt template for every request, it needs a way to know which schema contract to enforce. This strategy pattern router evaluates the channel parameter, email, mobile, or SMS, and activates the specific logic path. It calls 2 payload packets: the specific section details text guidelines and the structural format instructions from the schema. Right before calling the language model, the router takes both of these distinct payloads and dynamically injects them into the blank variables of the master prompt. Instead of maintaining completely separate files for every workflow, the core prompt code stays entirely static. Only the injected variables change. Abstracting the platform logic out of the core prompt and into a strategy pattern allows engineers to scale to dozens of channels without duplicating code. The section details payload injected for an email request is dense. It contains over 100 lines of precise textual constraints. The guidelines instruct the AI to use clever wordplay, mandate strict headline casing, and offer character limits to construct marketing copy across multiple blocks. The mobile instructions tighten. Space is limited on a phone screen, so the constraints explicitly prohibit including the product name in the notification subject line. By the time the router targets an SMS output, the generative freedom is entirely stripped away. The text instructions enforce absolute limits, exactly 80 characters maximum, no emojis, no hyphens. An SMS platform will physically truncate or break a message that exceeds its limits. These severe rules force the language model to comply with a medium that has 0 tolerance for formatting errors. The narrower the user interface endpoint becomes, the tighter the constraint engineering must be to guarantee successful delivery. After the AI processes the constraints and returns its raw, structured JSON response, the pipeline hands that data off to a dedicated Python parser function. This is where deterministic hybridization happens, the point where unpredictable AI generation is merged with hard-coded software logic. The email parser iterates through the AI's output, extracting the 5 unique variations of headlines and subheaders to build the final display elements. Here, you can see how 5 distinct text variations output by the AI are merged at their base. The parser discards the AI's varied button ideas and enforces a single identical call to action across all 5 blocks. Allowing a generative model to dream up variations for buttons invites broken navigation and lost revenue. Reliable enterprise systems intercept the raw text. They extract the creative copy, but override the functional elements with rigid, deterministic rules to ensure absolute safety. Sometimes a marketing campaign needs to trigger a secondary objective, like pushing a specific retail loyalty program that only applies to a fraction of the seasonal drops. Within the system's pedantic schemas, this loyalty action field is mapped as strictly optional. It defaults to an empty state. Rather than asking the language model to figure out if the program applies, the parser function simply checks the original input brief for an active loyalty flag. If the flag exists, the Python code manually appends the Join button right below the standardized Shop button. Delegating conditional business logic to traditional parser functions keeps the primary prompt focused on copywriting, ensuring the outputs remain clean when those niche rules do not apply. A single creative brief is passed to a central router, matching dynamic constraints to target destinations, executing through a locked data schema, and filtering out through deterministic Python parsers. It relies on schemas to enforce structural shape, strategy routing to isolate the execution logic, and rigid parsers to guarantee operational safety. Integrating artificial intelligence into a massive production environment requires an engineering mindset. It demands resilient, hard-coded software architecture built specifically to constrain and harness the behavior of a non-deterministic model.